Hello and welcome to the progress. I am Aravinda. In this session, we are going to discuss about ADITYA L1 mission. ADITYA. ADITYA is an ancient or alternative name given to the sun in the Indian system, and L1 refers to the Lagrange point 1. Therefore, ADITYA L1 is nothing but a solar mission sent by India or ISRO to be precise. And the point where this mission is going to get placed is also having huge importance. Let's look where it is going to get placed. So here there is sun and here there is an earth, and this is the point known as Lagrange point 1 or L1, and this is the position where ISRO placed the ADITYA system. Why ISRO placed ADITYA system in the L1? Why not in the other point? Or what is the speciality about this L1? Or what is the uniqueness about this L1 point? It is very important to study about this Lagrange point because it is the most scoring area. I mean, we can expect the question from this definitely in the prelims as well as in the mains. And one more thing, by understanding the Lagrange point only, we can understand the ADITYA mission in depth. For this, I made the separate video for the Lagrange point and I given the link in the description. Kindly do watch it for scoring marks. Now, coming to the objectives of this ADITYA L1 mission, the main objective of ADITYA L1 mission is to study the coronal mass ejection or to study the coronal layer of the sun. What is coronal layer? You may be having a doubt. To understand the coronal layer, we should know some brief history about the sun or brief fact about the sun. You all know Earth is having two layers, that is surface layer and the atmospheric layer. In the surface, we are having core, mantle and crust, and the atmospheric layer has been divided into troposphere, stratosphere, that is ozonosphere. Like this, we are having layers. In the same way, sun is also divided into two layers, internal or surface layer and the atmospheric or the external layer. First, we will see what are all part of the internal layer. Like the earth, in the crust, in the surface, we are having crust, mantle and the core. Even the sun's surface is having three layers, namely core zone, radiative zone, and the outermost zone is convective zone. These are the three surface zone. And coming to the atmospheric zone, it has been divided into first photosphere, then above photosphere we are having chromosphere, above the chromosphere we are having the corona or the solar wind. Therefore, here you are seeing this border, correct? This border is a position where sun's surface stops. Whatever you are seeing here, it is an air or heat coming out of the sun which has been trapped and it has been looking like a layer. So this is an atmospheric layer of the sun. And the bottommost layer is photosphere, chromosphere, then the corona. Generally, the above layer should be having less temperature compared to the previous layer. For example, if you are heating the water in the pan, means the top layer will be having less heat, but the bottom layer will be having the more water. More heat. This is the natural phenomena. But with respect to the sun, corona, the outermost layer is having more temperature compared to the previous layers such as chromosphere and photosphere. How this weird phenomena is happening? To understand this weirdness, many countries are breaking their heads. And now India also officially enrolled in this headache by launching this ADITYA mission. Now, I hope this layer concept is clear to you. Now we will see what is the uniqueness or speciality of this ADITYA mission or ADITYA L1 mission. This is the India's first solar mission. Even in the Chandrayaan case, it is the Chandrayaan 3, which means that is the third lunar or moon mission sent by the India. But with respect to the sun or solar, this is the first mission sent by the India as a country. And second speciality is this is India's second space-based astronomy mission. And previously, this is the AstroSat is the first space-based astronomy mission of the India. And this ADITYA is going to be the second space-based astronomy mission of the India. And space-based astronomy means it is like observing the, let's say, ultraviolet rays, X-rays in a multiple wavelength format. We are going to observe the space. That is known as the space-based astronomy. And this is the second mission for the space-based astronomy from India. And coming to the third important speciality is India became only fifth country after USA, Europe, Japan and China to launch a solar probe like this. Before India, we are having USA, that is NASA, ESA, that is European Space Agency, and JAXA refers to the Japanese Space Agency, and China. After China, we are the fifth country to demonstrate this. And this is the list of probes sent by the different countries in the solar. I mean, these are the solar probes sent by different countries. Try to remember the name and country which launched this probe. Because in the prelims, you might be getting a question like this. Like, for example, in this SOHO, ZOHO is there. SOHO is a solar probe satellite launched by Japan. Like this, they might be asking. So you should know ZOHO. It has been launched by ESA and NASA, that is European Space Agency and NASA in collaboration. And YOICO, sorry for my spelling, YOICO, which has been launched by the Japan. Parker, in 2018, recently it has been launched by the USA, that is NASA. Then in 2020, the USA and Europe collaborated in the Solar Orbiter mission. And recently, before India, China did Advanced Space-Based Solar Observatory mission in 2022 that has been demonstrated by China. And after this, India joined the list in 2023 by demonstrating ADITYA L1 mission. Therefore, these are the only countries launched and these are the name of the probe. Please have a look over this. Now, coming to the technical information. Before looking into technical information, we will look about the payloads. As you know earlier, payloads are nothing but additional instruments or accessories carried by that mission. Suppose if I am going out, I am carrying my mobile phone, I am carrying my watch, I am carrying the pen, means those are becoming my accessories or those are becoming my payloads. In the same way, Aditya mission carried some accessories with it, that is, it carried some payloads. And what are these payloads? We are going to study. And the important payloads carried by Aditya L1 is magnetometer. And main role of magnetometer is it is going to measure the interplanetary magnetic field. How was the interplanetary magnetic field is there? You know, Earth is having certain magnetic field. Sun is having some magnetic field. How is this interplanetary magnetic field? This is going to be measured by the magnetometer. Coming to next thing, aspects and PAPA. I am using the short form. You please look into the slide and make note of this. Okay, aspects and PAPA is going to study the solar wind and energetic ions as well as how the energy is going to get distributed among everything. And next important payload is SOLEX. Then high energy orbiting X-ray spectrometer. Then SOOT, Solar Ultraviolet Imaging Telescope. This is going to be like a kind of telescope which is going to observe. And then VELC. You just pause the video and make note of this payloads and try to know what these payloads are doing in a simple term. No need to go into the technical detail. As you know, in the Chandrayaan 3, we used the payload known as CHASTE. It is acting as a thermometer. It is going to measure the lunar temperatures. In the same way, here some payloads are used. You might be getting a question. CHASTE is a payload used to measure the temperature in the solar surface. They might be asking. Then CHASTE is the payload of the lunar surface. You should know. Therefore, be sure about the payloads. And these are the payloads, how the payloads are going to look. Now coming to the technical details about this Aditya L1 mission. This Aditya mission launched recently during the September month of the 2023. After the Chandrayaan 3 successful launch, now we are launching the Aditya L1 mission in the September. And the destination planned for this Aditya mission is Lagrange point 1. And the carrier which carried this mission is known as sorry for my spelling mistake, it is not PSLC, it is PSLV, that is Polar Satellite Launch Vehicle. PSLV C57 model carried or lifted this Aditya mission to the L1 orbit, to the L1 point. Therefore, this is the carrier. With respect to the Chandrayaan 3, what is the carrier? Which rocket carried the Chandrayaan 3? Please put your answers in the comment section. Which rocket or which which rocket carried or lifted the Chandrayaan 3 to the space. Please mention whether the instrument is same like PSLV or the instrument is different. Please tell your answer in the comment section. And this is India's first solar mission. We discussed this in the uniqueness point. And this is the second space-based astronomy mission after the AstroSat. All this we discussed in the uniqueness point. So this is the thing you have to know about the Aditya mission L1. And please, I'm telling again, try to watch this video regarding the Lagrange point, because by understanding the Lagrange point only, you can understand the Aditya mission properly. That gives you key to open the treasure. Therefore, please do watch this Lagrange point video also, for which I given the link in the description. Thanks for being with me. I hope the session is clear to you. If you are having any suggestion, queries or doubt, please feel free to ask or communicate to us. Thanks for being with me. Have a great day.